Okay, let's start with the Laplace transform, but before watching what is the Laplace transform, we are going to see what is any transformation, okay? Now, in the past you have already seen transformations. One transformation that you have seen is something like this. The transformation I see is like a tortillas machine. Um, in a tortillas machine, what you get is you get inside mass, and what you get as an output is tortillas. That is in general a transformation. But in mathematics, transformation could be transformation of numbers, transformation of functions. Alright? Okay, in mathematics you have seen transformations and you already know transformations. So let's assume these tortillas machines where you set inside the x square and you get as an output the 2x. Alright? Okay, and you get inside the cosine of x and you get as a result the minus sine of x. Okay, you set the natural log of x and you get as an output the 1 over x. Okay, I guess you have figured out what is the transformation. The transformation here is the derivative respect to x. Alright, so that is a transformation. So here you are not transforming mass to tortillas, you are transforming functions into another functions. Alright, now there is another transformation that you have already seen. Is, let's consider another tortillas machine where you get here, for example, let's say that you throw um, 1 over x in the input and you get as an output the natural log of x. Another example, let's say that you here throw the cosine, well, the sine of x, and you get the minus cosine of x as an output, right? Okay, I guess you have already figured out what is the transformation. The transformation is the integral of the differential of x, right? Now, what is the common between these two tortillas machine? Okay, this one is the integral and this one is the derivative. They happen to be opposite transformations. Okay, so here you get the 1 over x and then you throw it back here and you get your original function. So it's doing the opposite transformation. Now imagine inverse transformation of the tortillas machine. Then it will be something like this, where you have the tortillas machine, you throw inside the tortillas and you get the mass. All right. Well, in reality, there is not such inverse transformation of the tortillas machine. All right. But in mathematics, we do have the opposite transformation. All right. Okay. Now, so that is the concept of transformation. So in the Laplace transform, that we are going to see is how to make transformation of functions. But before jumping into the definition of the Laplace transform, just let me remind you what is the definition of the derivative. Usually you get the derivative of the function like this. But in reality, the definition is something like this. The limit of the x plus h, f of x plus h minus f of x divided by the h, when h tends to 0. So this is the definition. Alright? Now, we no longer use the definition. We use the derivatives, the table of the derivatives that includes the definition. We no longer use the definition, we just go to the formulas. Alright, now, for the integral tortillas machine, you also have a definition. Let me see if this is the definition. The integral of the function with respect to x is equal to the sum when n equal to 0 to n from index equal to 0 or 1, whatever, of f of x I times delta x, right? When in the limit when n tends to infinity. So that is the definition. Now, in fact, this symbol of the transformation is the symbol of the addition. It's just an s, make it large. A large version of the s is just a sum. Alright, so that is the definition of the Laplace transform. Actually, in the history of mathematics, the mathematicians didn't know that the derivative and the integrals, they were opposite operations. Alright, they discovered that later with some theorems. Alright, now before jumping to the Laplace transform, one important concept, linearity. Linearity. Okay, we want the transformations to be linear. We want linear transformations. Why we want linear transformations? Okay, let's use common examples, common life examples. Imagine that this is the tortillas machine, the transformation, but here the transformation is currency transformation. Currency transformation. So you insert here $1, okay, and you get 22 pesos. So that is the transformation, all right? Okay, now linearity means this. If you have here in one time you have $2, and then in another time, in another period of time, you have $1, $1, right? And you make the transformation to pesos. So what you get here is 44 pesos, all right? But here you make another money exchange later of $1, and you get as an output 22 pesos. Okay, now linear is this. Now you do this transformation today and tomorrow, or yesterday and today you do this transformation. But what if you waited and transform everything in one single shot? So imagine that you have here, instead you have the $3. Now you get how much? You should get 66 pesos, and that is linear. We expect the transformation to be linear because no matter when you do it, separately or together, you should get 66 pesos. Well, the addition of these two, all right? But some systems are not linear. Imagine that you get, instead of 66 pesos, you get 60 pesos. So that is non-linear. Non-linear transformation. But you get 66 pesos, which is the addition of the two, then is linear transformation. Alright, so no matter when, you can do it separately or you can do it together, you should get the same transformation. If you don't get the same transformation, then it is not linear. So we want things to be linear. Now, imagine another example. You have the currency transformation machine where you throw $0. Okay? Now, what do you expect to get as an outcome? Now, what if you get 5 pesos? That is not possible. So that is non-linear. Non-linear. Linear transformation. But what you expect is if you throw $0, then you get 0 pesos. It is expected because it's impossible. If you don't have $0, it's not possible that you get the transformation 5 pesos. Alright? You should get 0 pesos. So that is linear. So the 0 in any currency, pesos, euros, dollars, should be the 0 in the other currencies. Okay, that should be linear transformation. Okay, so do we have this kind of linearity in the derivatives of the integrals? Yes, because the derivative of 0 respect to x is equal to 0. Okay, or so that is for the 0. But what about this? The derivative respect to x of f of x plus or minus g of x is equal to the derivative respect to x of the first function plus or minus derivative of g of x respect to x. So here is distributive property, distributive property. So no matter if you make the transformation together or you do the transformation separately, just like here the currencies. No matter if you do $2 transformation and then $1 transformation and then you make the addition, or you do the addition before and get the transformation. So it doesn't matter if you do it together or separately, you should get the same result. And the last property, derivative in respect to x, and you should know this, k times f of x is equal to k derivative of the function respect to x. We know this, commonly know this as taking the constant outside of the operation. And that is true because in the currencies example, if you do the multiplication here times 2, it should be the same as making this transformation then times 2. So the constant can be taken outside of the transformation. And that is a linear transformation. A linear transformation combines this distributive property and the constant outside and the zero. All right. Now, with this background about what is a transformation and what is a linear transformation, let's jump to the Laplace transformation definition. Okay, so that is the next.